Okay, now we want to prove that given F a linear map from E to F, then that is a bijection, then the inverse map is also linear. So that's very important because it's, well, we're talking about this bijection concept, which is going to be very important for us from now on. So a bijection from E to F, it means that for any map, it doesn't have to be linear. For any map, that if it defines a bijection, it means that there exists an inverse function that goes from F to E, and you know that this inverse function is defined such that F minus 1 applied to F to any item X in the domain of X gives you X. Okay, and also we have that for any Y that belong to the domain of F minus 1, we have that F applied to F minus 1 of y, it's equal to y. Okay, that's the definition of the inverse function. And so we want to prove that if we have a map F that is linear, and that is also invertible, that is a bijection, so we have a word for that. We say that F is an isomorphism from E to F. Okay, that's an important word. So that means F minus 1 goes from F to E and it exists. Okay, so we want to show that this F minus 1 is linear also. So let's work on F is linear. F is linear, it means that for any x1, x2 that belongs to E, any lambda that belongs to R, we have f of lambda x1 plus x2 is equal to f of lambda times x1 plus f of x2. Here I have just translated the fact that f was linear. Okay, so let's give some names to what we have. Let's say that let's put y1 is equal to f of x1 and y2 is equal to f of x2. Okay, so this is really y1, lambda times y1, and y2. Okay, so now let's apply f minus 1 to this to this equality on both sides. Okay, so I'm going to apply f minus 1 here, and I'm going to apply f minus 1 here. Okay, so I've got on the left hand side f minus 1 applied to f here of anything. It just gives me the anything, so that's lambda x1 plus x2, and on the other side it's equal to f minus 1 of lambda y1 plus y2. But we also know that this is what we had, so I can also rewrite it with f minus 1. We can also say that f minus 1 of y1 is equal to x1 and f minus 1 of y2 is equal to x2. So that next thing we can get is that lambda times x1 can be written as lambda times f minus 1 of y1, and y2 can be written as f minus 1 of y2. This is equal to f minus 1 lambda y1 plus y2. And this is it. We just proved that f minus 1 was a linear map from F to E. Okay, indeed, because f minus 1 applied to any linear combination of elements of F, this one, is giving me the linear combination of the images.